All right, let's do some exploring today. We're going to be talking about the converse relationships. So we are kind of going backwards, but first, of course, we're going to do some bell work. So we're going to find some measures of some missing angles. So number one, it says find the measure of each angle. So we can easily fill in what all of our missing angles are just knowing this one piece of information, right? So we got parallel lines, right? Well, parallel lines I can do a whole lot of things with, but I'm going to be really easy on myself, and first I'm going to do my vertical angles. So 79 over here, we got 79 over there. Then I can find the one missing next to it because we have a linear pair. So 180 minus 79 is going to give me 101 for my missing side. And again, I have vertical angles, so this one is also 101. I filled in the top four. I can easily fill in the bottom four because we have corresponding angles. You can shift this whole thing on top of this whole thing, and it's going to be the same. 101 over here, this is corresponding. 79, this angle is corresponding. 79 up here, that's a corresponding angle, and 101 over here, again, corresponding angle. You can check as well. I mean, we have same side interior angles here. They're equal to 180, right? We have alternate interior angles. They're congruent. Alternate interior angles, they're congruent. So let's come on over here. I know that this is 90 degrees, right? So that one's pretty easy. But I can also fill in everything else really fast. This is 90. Well, here's a linear pair. 90 is the other side of my linear pair. So this is also going to be 90 degrees. I can come up over here, linear pair, vertical angles, however you want to do it. We got 90 degrees. I can do the same here. What? Linear pair, vertical angles, 90 degrees. So again, the same relationships are happening over here as they are over here. I can shift this down. This is going to be 90. This is going to be 90. Right? This is going to be 90. And just for fun, I can solve this one if I want for x, even though it doesn't say to. That's equal to 90. So 22x minus 2 from both sides. So let's subtract 2 over here, subtract over here. I get 88. Let's divide by 2. So x is going to give us 44, right? So again, be smart. Use your relationships. All right, let's go ahead and solve for this one. Now, I've got parallel lines. I need to figure out the relationship between these two. Here's my parallel lines. Here's my transversal. This angle right here, this angle right here, they're inside my parallel lines, so I know they're going to be interior angles. And they're on opposite sides of the transversal, so I have alternate interior angles, which means parallel lines, they are congruent. So let's set them equal to each other. N squared minus 21 equals 4n. How am I going to attack this one? Well, I've got a quadratic. I can solve it if I factor it, but first I have to get this equal to 0. So let's take 4n from both sides. If I subtract, I get n squared minus 4n minus 21 equals 0. I got to find something that multiplies to negative 21, adds to negative 4. Well, 7 and 3 will do it. Which one has to be negative? The bigger one. So I have n minus 7 and n plus 3 equals 0. I'm going to solve, so I get n equals 7 or negative 3. However, if I plug negative 3 back in over here, I'm going to get 4 times negative 3, which would give me negative 12, and I cannot have a negative answer. So n equals 7 is going to be the final answer for that one. However, if I want the angle relationships or measures, I'm going to have to plug it back in. So 4 times n is going to give me 28. So this angle is going to be 28, which means this angle is also going to be 28 because alternate interior angles. That's how we set them up, right? I can fill in some vertical angles fast. So these guys are going to be congruent. These guys are going to be congruent. And then to find the other missing angles, I'm going to have to use that linear pair relationship or same side interior, which is the same because they're sup. So 180 minus 28 is going to give me 152. So that's my other missing angle. So 152 here, 152 here, 152 here, and 152 here. All right, so once you figure out the two angles, you just got to figure out where to plug them all in, right? All right, let's talk about the converse relationship now. So our learning target today is going to be to determine if the converse of angle relationships are true or not. So, right, when we're talking about converse, we're talking about the reverse. So we know that if we have parallel lines and alternate interior angles, then they're going to be congruent. Well, I want to know that if alternate interior angles are congruent, can we prove parallel lines? So let's take a look, right? So again, if we have parallel lines, then corresponding angles are congruent, right? So corresponding angles are congruent if we have parallel lines. If the lines are parallel, right, then alternate interior angles are congruent, right? If the lines are parallel, then blank are supplementary. Well, which ones are supplementary? We've got same side sup. So either same side interior, same side exterior. They're both going to be supplementary if lines are parallel. If the angles are vertical angles, then they are congruent. That's always true. Bow ties are always going to be true, right? And if two angles form a line or linear pair, then they are always supplementary, right? So those are our special cases where we don't need parallel lines. All right, so now let's look ahead at the diagram, right? So we want to do a little bit of exploration here. So in the diagram, what is the sum of angles x and y, right? So if I look at angle x and angle y, what is the sum? Well, I'm going to guess you're going to look at this diagram and say, all right, I've got some lines here. I've got a transversal. Those are interior angles. So same side sup, right? So we're going to say 180 degrees. Same side sup, right? But do we know lines are parallel in this situation? No, we don't. We don't have anything that determines whether these lines are parallel. So the question is if these, how can we determine whether or not the angles are 180 degrees? All right, well, let's think about this. Pause the video after you read this question and think about it for a minute before you come back. It says, take a few minutes and think about why the diagram can't be true, right? So think about the relationship we have going on here. 100 degrees for this angle and 80 degrees for this angle. And if you look at this picture, it appears that eventually these two lines are going to intersect. Right? They do not appear to be parallel. But think about what this figure would be, right? What is this figure going to be? You got it. It's a triangle, right? Well, what do we know about the interior angles of a triangle? Well, from the interior angle sum theorem, we know all three angles of a triangle are going to equal 180 degrees. Well, we have 100 and we have an 80 for these two angles. So 100 plus 80 is 180 degrees. What would make this angle what would that angle be then? If these two are 180, that would make this angle 0 degrees. Is that possible? No, it is not, right? We cannot have an angle that's 0 degrees in a triangle. Therefore, if these two angles are going to be 180 degrees, right? So if they add to 180 degrees, it forces lines AB and CD to straighten out, right? They cannot intersect because we would have a triangle with a 0 degree, right? So that means that if we can prove interior angles are 180 degrees, right? Same side interior angles are 100 degrees, then we can also say that our lines are parallel, right? So, again, looking at this, right? SpongeBob is not convinced that lines in this problem must be parallel. She decides to assume that they are not parallel and draws a diagram to the right. Why must lines AB and CD intersect? The reason they have to intersect is because we cannot have a 0 degree angle in a triangle, right? Not possible. Therefore, if these two angles are going to be 180 degrees, this cannot happen, right? They cannot intersect. It forces them to straighten out and be parallel. Very cool, right? So again, in this diagram, do my lines have to be parallel? Well, let's check. We've got 113 degrees and 67 degrees. These two angles, same side of my transversal, inside my lines, 113 plus 67 degrees is 180 degrees. We have 180 supplementary angles. Therefore, we know this line and this line can't meet, can't make a triangle because we ran out of angle measurements. So line L and line M must be parallel because our interior angles are supplementary, right? So the converse is true. If same side interior angles are supplementary, then lines must be parallel. Right? We can keep going through our process using the idea of corresponding angles, and we can use the idea of alternate interior angles, right? It would mean that we just have to find some of our linear pairs and again prove that it is also true. So 80 degrees on this side, this angle has to be 100 because it's a linear pair. Now I've got same side interior angles that make 180 degrees. These lines cannot intersect, right? Alternate interior angles are congruent. Again, I can figure out this angle is going to be 100 by a linear pair. These two are supplementary now. These lines can't intersect, right? So the converse of all three of our theorems is also true. If same side interior angles are supplementary, then lines must be parallel. If corresponding angles are congruent, then lines must be parallel. And also, if alternate interior angles are congruent, lines must be parallel, right? So again, we're going to rewrite, I would like you in your notes to rewrite these statements as the converse, right? So if the lines are parallel, then same side interior angles are sup. Well, the converse of that says if same side sup, then lines are parallel. Again, if lines are parallel, then alternate interior angles are congruent. Converse, if alternate interior angles are congruent, then lines are parallel. And finally, our last one, if the lines are parallel, then corresponding angles are congruent. Again, converse, if corresponding angles are congruent, then lines are parallel. Okay, so converse is also true, right? If we can prove these relationships are happening, we can prove parallel lines, right? All right, so let's look at a couple of examples now that we know. So we want to find the value of x that makes these lines parallel, right? So we're trying to make this relationship happen. So if this angle and this angle are the angles that we have, we know that these are alternate, because they're on the opposite side of the transversal, but they're inside my lines. So these are alternate interior angles. If we want lines to be parallel, we need alternate interior angles to be congruent. In order to make that happen, we have to set them equal to each other, right? And then we just solve. So 16x equals, I'm going to add 6 to both sides, 96. I'm going to divide by 16 on both sides, giving me 6. All right, so x must be 6, and then I'll have alternate interior angles congruent, and then I have to have parallel lines, right? So alternate interior angles will be congruent if x equals 6, and if alternate interior angles are congruent, I must have parallel lines. All right, let's look over at this one. Again, this relationship, right? We've got on the same side of the transversal, but one's on the inside and one's on the outside, so I have corresponding angles. Therefore, if parallel lines, corresponding angles must be congruent. So let's prove that, or let's make them congruent and see what we need x to be. 12x minus 4 equals 10x plus 10. If I subtract 10x to both, or let's add 4 to both sides first. We'll add 4 to both sides. We get 12x equals 10x plus 14. I will subtract 10x from both sides, giving me 2x equals 14, divide by 2, so x equals 7. So I need x to equal 7. Therefore, my corresponding angles will be congruent. And then I have parallel lines. So we're going backwards now, all right? So see if you can work on tonight's homework for 3.1, and we'll come back tomorrow and do a little bit more with our converse.